So for our next topic, it is to describe security password policies elements such as management, complexity, and password alternatives, which includes multi-factor authentication, certificates, and biometrics. So how do we keep unauthorized users out? So one strategy is to use strong passwords. This is known as password complexity. These are password policies that may require a user to have capital letters, numbers, special symbols, and or lowercase letters in their password, and the user cannot repeat the character, a user cannot use a dictionary word or their name in the password, and the password must have a minimum length. So these are examples that are usually found in strong or fairly complex passwords, but they differ in different organizations, systems, and or platforms. Passwords that are easy to guess represent security risks because they can be broken in by brute force. So we can manage user passwords centrally through an Active Directory or a Radius server. So what is an Active Directory and a Radius server? So our Active Directory, wherein the user creates a password, an algorithm transforms that password into an encrypted output known as a hash. Hashes are of fixed size, so passwords of different lengths will have the same number of characters, similar to what we did when we figured our router with a local password in the command line interface or the CLI, which was when our encryption was enabled. And meanwhile, the radio server or the remote authentication dial-in user service is a client-server protocol and software that enables remote access servers to communicate with the central server to authenticate dial-in users and authorize their access to the requested system or service. So, an example of a good password policy has the following. They require users to choose complex passwords. They require users to change their passwords often and locks user accounts if the password was entered incorrectly several times in a short period. But even when complex passwords can be guessed or seen by unauthorized users, as phishing and social engineering attacks grow more complex, it is more likely that a user will be tricked into giving up his credentials without even realizing it. So how can we keep our network safe if the hackers can trick our users into handing over their passwords? Here are three simple ways, which are the multi-factor authentication, our certificates, and our biometrics. So multi-factor authentication means having to provide more than just your username and password. The principles of multi-factor authentication are important. The three main factors are something you are, something you have, and something you know. Basic authentication methods combine something you have with either something you know or something you are. So something you are refers to biometric identity such as facial recognition, fingerprints, voice recognition, or a retinal scan. Select the best type of biometric for your environment. Something you have refers to a smart card, an ID card, or a username. It could also refer to a randomly generated password such as an RSA, secure ID, or an authenticator app. Something you know Something you know refers to probably a password or a PIN. And for something you do is an observation of the user's actions or behaviors. In Windows, a user can choose a picture password. In an Android phone, the user can interact with a pattern. And here next, from our certificates, instead of entering a username and a password, a user can present a certificate to the authentication server. A certificate is a digital file that confirms the identity of a user or a device. A certificate must be signed by a certification authority. IEEE 802.1x is a standard for network access control. It allows a device to authenticate when connecting to a LAN or WAN. There are three devices in a protocol. The supplicant is a device that chooses to connect to the LAN or the wide area network. It could be a laptop, desktop, smartphone, tablet, or other computing device. The authenticator is a network device that allows or denies access. It could be a switch, a router, a firewall, or a proxy server. The authentication server is a server that decides whether a device should be granted access. And for our next authentication is our biometrics. So biometrics are used in combination with other devices to provide an additional layer of authentication. These include facial recognition, fingerprint reading, voice recognition, palm reader, and a retinal scan. So a biometric reader takes a photograph of a human body part and then converts it into a mathematical model. For example, a fingerprint reader understands the bumps and ridges on a fingerprint and compares their relative sizes. There are many different algorithms and each one is different. Not every scan is perfect. Most biometrics have a false positive because of the algorithm. The false positive rate for a fingerprint sensor is approximately 1 in 50,000. A biometric reader does not and cannot create a pixel by pixel comparison of a person. Imagine taking a photograph of your face 100 times. Each photo will be slightly different. The lighting, the reflection, the angle of your head, and the position of your hair will be slightly different each time. So what are the pros and cons of the different biometric devices? So for the fingerprints, a fingerprint scanner maps a person's fingerprint and converts it into a mathematical signature. The signature is then stored. It later compares new scans to the original mathematical signature. Advanced fingerprint scanners can verify that a real finger has been scanned as opposed to a mold of a finger. Fingerprint scanners are cheaper than other biometric sensors. And the retinal scan uses a laser to examine the blood vessels in the back of the eye. And the retinal scans are unpopular because they require a user to have a laser shine into his eye, and the user must also put his eye up against the sensor. An iris scan photographs the front of an eye from a distance, and iris scanners are more popular than retinal scanners. Voice recognition is hard to implement. Voice recognition sensors have a high rate of false positives and false negatives. So in voice recognition, as you can see here, there are more cons as there is to pros. And in the facial recognition scans features that are present on the user's face, and facial recognition systems work really well.